In this lesson, we are going to talk about linear equations in two variables. A linear equation in two variables is an equation in which the variable appears in separate terms and each variable has an exponent of 1. So here we have y equals negative x plus 8. Notice the exponents are 1. Sorry, that's my dog scratching. That's his collar. The exponents are 1 here and here. We don't write the exponents in math class when they're 1, so you will not see the exponents when they're 1. Okay, so what we're going to do is we are going to find solutions to this equation. So we have y equals negative x plus 8. So solutions of a linear equation are ordered pairs that make the equation true. Now remember, x is independent, so we can assign values for x, and y is dependent on whatever x is. So what I like to do is I like to make sure that we have a negative value, 0 of course, and then positive values. So I just keep it simple. Negative 1, 0, 1, and 2. So that's what we pick for x. Now we're going to plug in these values for x. So we have y equals a negative 1 plus 8. So a negative 1 is 1, and 1 plus 8 is going to be 9. So that's our first ordered pair, our first solution. Negative 1, comma, 9. Now we're going to plug in 0. So we have y equals a negative 0 plus 8. Now negative 0 is just 0. So 0 plus 8 is 8. So we have 0, comma, 8. Our next one is 1. So we have y equals a negative 1 plus 8. A negative 1 plus 8 is 7. Hopefully you see the pattern by now that as x goes up by 1, y is going down by 1. So we have y equals a negative 2 plus 8, which is 6. So we have 2, comma, 8. So here are all the solutions, well, some of these solutions for this linear equation, y equals a negative x plus 8. Let's try another one. Let's find 4 solutions for the equation y equals 2x minus 1. Go ahead and pause the video here and see if you can fill out this table. And you can pick any values you would like. Go ahead and pause the video. I have an extra x here. Okay, so again, I'm going to choose negative 1, 0, 1, and 2. So we have y equals 2 times a negative 1 minus 1. So that'd be a negative 2 minus 1, which would be a negative 3. So our first order pair is negative 1, negative 3. Then we have y equals 2 times 0 minus 1. So that'd be 0 minus 1, which is a negative 1. Then we have y equals 2 times 1 minus 1. So 2 times 1 is 2, minus 1 is going to be 1. So that's going to be 1, comma 1. Hopefully you see the pattern now. What's happening to y? Y equals 2 times 2 minus 1 is going to be 3. So it's going to be 2, comma 3. Do you see the pattern? It's increasing by 2 each time. Isn't that a coincidence, though, that we're increasing by 2 and the coefficient in front of x was 2? Look at the last example. We were decreasing by 1 and the coefficient in front of x was a negative 1. Very interesting. Now here's the next one. Now this one's a little different. We have 3x plus y equals 8. Now, it'll make your life a lot easier if you solve for y, meaning get y by itself. So you have to get the x to the other side of the equation. So how can we do that? Well, why don't we do what we've always done and take, since we're trying to isolate y, do our railroad tracks. Now this is a positive 3x, so we can subtract 3x from both sides. Now be careful. You have to make sure you can only combine like terms. We have a naked number here and a minus 3x. Now can you put those together? No, you cannot. Okay, so with that said, y equals a negative 3x plus 8. So again, choose your values, negative 1, 0, 1, and 2. Go ahead and pause the video. Okay, so this is what your table should look like. Do we see another pattern? Yes, we're decreasing by 3 each time, and what do you know? It's a negative 3 on the coefficient of x. This is not a coincidence. This coefficient on x is going to tell you what's going to happen with y. We're going to use this in future lessons. So solving for y, I believe, is probably one of the hardest parts of this lesson. So let's practice solving for y. We want to isolate this variable. We want to isolate y. So isolating y, you can do your railroad tracks if you wish. And this is a positive 3x. Just like the last example, we're going to subtract 3x from both sides. Now sometimes you might put it right underneath the 10, but I put it off to the side because I know I cannot combine these like terms because this is an x and this is a constant. And in my class we call it a naked number because it's not closed by an x. So we always put the x's first. Okay, we always put the x's first, so get used to that. Now notice there's a negative 1 here, or a negative sign in front of the y. How can you get rid of that? Well, you can divide by negative 1, but if you're going to divide y by negative 1, you have to divide everybody by negative 1. Because in math class, we're nice people, and whatever you do to one side, you got to do the other, and you don't leave anybody out. So we have y equals 3x. Positive 10 divided by negative 1 is a minus 10. If you have plus a negative 10, that's not going to hurt, but I'm just going to write minus. Okay. Now pause the video and see if you can do this next equation. All right. If you got this, the railroad tracks, then you added 4x over, Then we have y equals 4x plus 2. And y is already by itself, so that's our linear equation. We're going to leave it just like that. All right. That's all we have for now. We'll go over this on Monday. Thank you.